Okay, in this video we are going to learn how to solve equations with radicals in them. So if you've noticed, we've done a lot of things with radicals. We've added, subtracted, multiplied, divided, which is rationalizing, and then we are now learning how to solve radical equations. So solving radical equations is very, very similar to solving a regular equation. For example, if I had the square root of x, that's supposed to be an x, sorry. The square root of x, let's even say it's 2 times the square root of x, plus 4 equals 10. Okay, so if this did not have the square root of x, we would just move the 4 and move the 2 to solve it. So let's go ahead and do that. So I need to move the plus 4. To move the plus 4, I'm going to do the opposite of that. I'm going to subtract 4 from both sides. And I get 2 times the square root of x equals 10 minus 4, which is 6. So now I have 2 times the square root of x. I need to undo the 2, so I'm going to divide both sides by 2. And I get the square root of x equals 6 divided by 2 is 3. And then now, to solve for x, I need to undo the square root. The way we undo a square root is we square it, okay? So that's the big thing here, is to undo a square root, you must square it. Okay, so to undo the square root, I'm going to raise both sides to the second power. And this square and square root undo each other, and I'm left with x over here, and 3 squared is 9. The big thing about these problems, though, is you must check your answer. And the reason why is because of kind of the idea of, like when we were having to take the square root of things, we had 2 answers. It was either plus or minus. It's kind of with that idea. When I square something, if I squared a negative here, I could end up with this answer, or if I square a positive, I could end up with this answer. So that's kind of what it all comes down to, and you'll see some examples like that. Okay, so let's do some problems. So my first problem, I just said we need to check it, and we never did. Sorry. Let me check the answer here first, and then we can do some problems. Okay, so my equation was 2 times the square root of x plus 4 equals 10. So let's plug in my answer of x equals 9. So 2 times the square root of 9 plus 4, does that equal 10? The square root of 9 is 3, so this is 2 times 3 plus 4. 2 times 3 is 6, and does 6 plus 4 equal 10? Yes, it does. So my answer is 9. Okay, so let's do some problems now. Our first problem we're going to do is the problem, the square root of 2x minus 3 equals 9. So if I had this problem, so notice x is being multiplied by 2. We're also subtracting 3 from it. We're going to do the opposite of both of those operations in just a minute. Before I get there, though, notice it's square. I'm taking the square root of all that. So I need to undo the square root first. The way I undo the square root is to square both sides. So on the left-hand side, square root squared, those undo each other, and I'm left with 2x minus 3. On the right-hand side, 9 squared is 81. And then I need to solve both sides, or solve for x. So I'm going to move the 3. So I'm going to add 3 to both sides, and I get 2x equals 84. And then divide both sides by 3. Nope, divide both sides by 2. And when I do that, 84 divided by 2 is 42. Before I for sure say that's my answer, I need to check it. So let me go back up to my original problem and check my answer. So this is my check. So the square root of 2 times x is 42, minus 3, we want to see if that equals 9. That was my original problem. 2 times 42 is 84. 84 minus 3 is 81. And the square root of 81, equals 9, which is true. So 42 is my answer. Okay. Let's do another one. If I had the problem, the square root of 3x minus 5 plus 7 equals 14. So when I go to work this problem out, I have the square root of all the stuff on the inside, but then I also have this plus 7. the first thing I have to do is move that 7, because if I tried to square both sides, I'd have to square, and you actually have to FOIL this, and it's a big old mess. So move the 7 first. So subtract 7 from both sides, and I get the square root of 3x minus 5 equals 14 minus 7, which is 7. Now I want to undo my square root by squaring both sides. So square and square root undo each other. I'm left with 3x minus 5. On the right-hand side, 7 squared is 49. And then we're going to work this out like a regular equation. Move the 5, add 5 to both sides. I get 3x equals 49 plus 5 is 54. And then divide both sides by 3. And I get 18. Okay, so just to make sure this works, let me plug it back into my original equation. The square root of 3 times x is 18. 3 times 18 minus 5, and then plus 7 on the outside. Let's see if that's equal to 14. So 3 times 18 is 54. And then 54 minus 5 is 49. 49, square root of 49 is 7, and 7 plus 7 does equal 14. So this is the correct answer. Okay, so let's do another problem like that, but let me show you one that doesn't really work out like that. So if I had the problem, the square root of 2x minus 5 minus 7 equals negative 14. Okay, so it's kind of similar to the problem before, but when we work it out, there's a few things different about it. So still, the first thing I need to do is move this 7. The way I move that 7 is to add 7 to both sides of my equation. And I get, these undo each other, so I'm left with the square root of 2x minus 5. Negative 14 plus 7 is negative 7. Okay, so then I'm going to undo the square root. So I'm going to square both sides. And when I square both sides, the square and square root undo each other. So I'm left with 2x minus 5 on the right-hand, on the left-hand side. On the right-hand side, negative 7 squared is positive 49. And then I work this out. So I'm going to add 5 to both sides. And I get 2x equals 54. Divide both sides by 2. And 54 divided by 2 is 27. Okay, so I got an answer. Let me check it and see if it works. When I go to plug it back in, square root of 2 times 27 minus 5, and then minus 7 equals negative 14. Okay, so 2 times 27 is 54, so this is the square root of 54 minus 5. 54 minus 5 is 49. And then here, the square root of 49 is 7. 7 minus 7, does that equal 14? No, because 7 minus 7 is 0, not 14. So this answer is not a real solution. It actually doesn't work, okay? So my actual answer here is no solution. Okay, so sometimes when you plug it in, it doesn't work. If it doesn't work, that means that answer you got actually doesn't work. So there's actually no solution to that problem. Okay, so cube root works the same way, essentially. If I had the problem, the cube root of x plus 1 and then plus 5 equals 3. I'm going to cube both sides to get rid of the cube root. The first thing I have to do, though, is move this 5. So I'm going to subtract 5 from both sides. And I get the cube root of x plus 1 equals 3 minus 5 is negative 2. And then I'm going to cube both sides, raise both sides to the third power. The cube and the cube root undo each other on the left-hand side, and so I'm just left with x plus 1. On the right-hand side, negative 2 times negative 2 times negative 2 is negative 8. And then when I go to solve for x, I add 1 to both sides, and I get, nope, don't add 1. You do the opposite of adding 1, which is subtracting 1, sorry. Subtract 1 from both sides, and negative 8 minus 1 is negative 9. You can check it and make sure it works. The cube root of negative 9 plus 1, and then plus 5 equals 3. Negative 9 plus 1 is the cube root of negative 8. The cube root of negative 8 is negative 2. Negative 2 plus 5 does equal 3. So negative 9 is my answer. Okay. That's essentially the lesson. I do want to go ahead and show you one that kind of works out like a quadratic, because you may run across this in the future. So this will be our last problem. If I had the problem, the square root of 4 minus x equals x minus 2. So for this problem, I actually have x's on both sides, but I need to get rid of the square root. So to get rid of the square root, I have to square both sides. On the left-hand side, the square and the square root just undo each other, and so I just am left with 4 minus x. On the right-hand side, though, x minus 2 squared actually means x minus 2 times x minus 2, and you have to FOIL it out. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. These don't cancel out because it's negative 2 plus negative 2, which is negative 4x. I'm sorry, negative 2x plus negative 2x, which is negative 4x. So I get x squared minus 4x plus 4. Okay, so notice, look what you have here. I have a 4, I have an x, I have an x squared, I have a 4x and a 4. So I have like terms with the 4s, like term with the x's. I also have this x squared. Okay, so that means it's a quadratic. How do you solve a quadratic? Well, we've learned 3 ways to solve a quadratic so far. Factoring, quadratic formula, or square roots. This is not a square roots problem, so we're going to have to factor it or use the quadratic formula. To do either one of those, it has to equal 0. So that's our goal here, is to make it equal 0 so that I can either factor or use the quadratic formula. So I'm going to keep my x squared over here. I'm going to move these guys over here. So I'm going to subtract 4 from both sides. And I get negative x equals x squared minus 4x, and 4 minus 4 is 0. I'm going to add x, again, because I'm trying to get 0 on this left-hand side. So I have 0 equals x squared. Negative 4x plus x is, goodness, negative 4x plus x is negative 3x. Okay, so now I either need to factor or use the quadratic formula. You can use the quadratic formula. Your a value would be 1, your b value would be negative 3, your c value would be 0 over here if you were using the quadratic formula. It's actually super fast to factor this. Probably looking at it, you're not recognizing how you factor it because it's not like AC method, it's not the difference of two squares, and this is just a GCF problem. Notice they both have x in common. So I can pull out an x. When I pull out an x, left over is an x from the first thing minus 3. So that's factored now, super fast, and I solve by factoring. So remember, to solve by factoring, you set both factors equal to 0. So x equals 0 and x minus 3 equals 0, and solve them. This one's done, so it's just x equals 0. Over here, I add 3 to both sides. Okay, and just a reminder, so I have 2 answers here. Just a reminder, I need to plug them in and check them. So when I plug in, the first one, my problem again is square root of 4 minus x equals x minus 2. So when I plug in 0, the square root of 4 minus 0 equals 0 minus 2. I'm plugging in 0 for both of these x's. The square root of 4 minus 0 is just the square root of 4. Over here, 0 minus 2 is negative 2. Does the square root of 4 equal to negative 2? No, it does not. So 0 is not an answer for this. Okay. For the other one, if I plug in 3, I get the square root of 4 minus 3 equals, x is 3, 3 minus 2. The square root of 4 minus 3 is the square root of 4 minus 3 is 1. 3 minus 2 is 1. Does the square root of 1 equal to the square root of 1? Yes, it does. So the only answer here is 3. Okay, so before you only had one solution on this problem right here. You only had one solution, and when it didn't work, we just had no solution. Here I had two answers. One of them doesn't work, one of them does. So that's the only answer here. Okay, so I hope that this lesson was pretty straightforward. Again, if you have any questions, please feel free to email me, and I'd be happy to answer those questions.